Okay, now that you've had a look at what the final build will look like, it's time to get into the code for how we get this to work. Just a reminder that we aren't going to build in any way to steer this. That could also be a really cool addition, possibly using a servo motor or something like that, but we're not going to get into that today. Today's focus, or this build's focus, is primarily on getting it to go forward and reverse using a single motor, 2 microbits, and all the other finicky things that we spoke about. Let's have a look at the code that we're going to end up with. So you can see we've set up 3 different variables. We've got a few if conditions. We've got a while loop, a forever loop, an onStart event that we'll use as the program initializes as we start it up. So that's going to be really helpful for us to get going. The other block of code that we will of course need is going to be for the other microbit. As you know, we're going to need 2 microbits for this. This one is also just nice and basic, which is really cool. Now, important thing to remember as we go through this and as we look at this, this is not the only solution. It would be like saying to somebody, yeah, cross this bridge. Now there's probably a normal way to cross a bridge, but there are nearly infinite ways of crossing a bridge, whether you are rolling, skipping, jumping, carrying each other on each other's shoulders, whatever it might be. This is one way that I thought worked and worked quite well. It seemed quite efficient to me, and it's, yeah, gets the job done. But if you think of other ways, of tweaks, of all of that you'd like to do, then let me know. Otherwise, we're going to run with this. So I'm using the desktop version of Makecode for microbit. It'll look exactly the same and run pretty much exactly the same on the browser-based version. This one's just nice and easy for actually transferring the text file, the code, onto the microbits, but otherwise, no difference. Okay, so we start off by creating a new project. Here we already have our onStart event and our forever loop, which is going to be helpful. We're also going to just add one other thing in just a moment. But first, we know that we're going to be using our radio in order to send the signal from one microbit to another in order to get it to move. Very importantly, as you set this group, you'll see you can set it all the way up to 255. All the way down to 0. I'm just going to set it at 1 for now. You need to make sure that this group is the same on both microbits, especially if there are several of you doing this at a time. Then if all of you have your groups set to 1, then someone else across the room is going to push their A button on the 1 microbit, and it's going to cause your rover to drive, which is not ideal. So chat with each other and make sure that you have a unique group. I'm going to leave mine at 1. Next thing that we're going to do is create a variable. This first variable we'll call speed, and it's always a good idea, as you know, to be as descriptive with your and as precise as you can be with your variables. So we've created our variable over here, speed, and as we initialize, as we start, we're going to set speed to 0. Remember, variables, in case you have forgotten, are containers that we can store all sorts of data in, whether those be numbers, as we're using now. We could also use strings, which are words. We could use booleans, true and false, and depending on your language, you can store all sorts of different variables in there. We're just going to be using numbers pretty much for all of the variables that we're be using for this build. We're also going to make another one, and I'm going to call this one speed increase. And again, that's nice and helpful to remember, to try and be descriptive as you can with it. And if somebody else looks at my code, they're going to be able to see, well, this variable is to help increase the speed. I've also used camel case, which is just a convention that we use for JavaScript over here. Camel case is when you start with a lowercase letter and then the next word without spaces has an uppercase. Okay, so then we've got speed increase. We're going to drag that in. And let's start setting that at 50. That's a number that's kind of worked for me. But as you play, as you download code and shift it or whatever, you're going to be able to change this value. And that really is going to change how fast your motor spins up. I like mine to just spin up immediately, nice and quickly. You might find that it's better to start at a lower number, and then you'll see how that increases and makes your motor eventually go faster and faster. There's one last thing that I always like to put in. This is just a personal kind of touch. I like to just have an icon that shows, I like to use a tick to show that the program is ready to run. That if you've kind of transferred data over to your microbit, you can see that that's all ready to go, and you can disconnect and connect to your battery pack, and then you're up and running, and all your power and everything like that is running. Okay, now we are going to use our radio event, so we'll come over to our radio blocks over here and drag in an on radio received, and then you'll see here's a different variable that is automatically created when this microbit on group 1 receives a number from another microbit. So this event won't fire or won't be called, let's say fire, won't fire if it receives a variable from the other microbit that is, or a signal from the other microbit that is a string, that is words, or a Boolean, a true or false. So this is only listening for if it receives a number. Okay, so now let's look at what should happen. First thing that we want to happen is we want our motor to actually spin up. So we'll have change speed by speed increase. You'll see in our forever loop in a moment, we're going to have the speed at 0 always until it receives, our microbit receives this over here, receives a radio signal, a number specifically, then it's going to increase and actually run so that we don't have our microbit just spinning up constantly. We can control when it moves forward and backwards. The next one is another variable that we're going to set up called motor direction. We could have also called that drive direction or drive forward or reverse, whatever. I've chosen motor direction. This is going to help us decide whether or not our motor should be going forward or reversing. And we are going to set motor direction to the number that we received. You're going to see when we set up the other microbits and in our forever loop over here that our motor direction as a variable is either only going to store 0, which we'll use for our motor to go forward, or 1, which will then tell our microbit that our motor should be reversing. That's all going to happen here in our forever loop, and we'll obviously also need to just set up the other microbit to do that. So we're going to need to constantly check forever what should happen when motor direction over here is a certain value, and then the motor should spin and go in that direction. So let's go over to our logic and drag in an if condition, which checks if this condition is true, then it should run this code. So we want to check, again, under logic in our comparisons, if motor direction, go to our variables, if motor direction is equal to 0, we can leave that there because that would be the received number over here. If motor direction is 0, then we don't have our extension enabled yet. So what you're going to do is you're going to come down to extensions at the bottom over here, go to extensions, and we're going to look for the code for our Kitronic motor driver board, which is just a really cool and easy way of getting motors up and running with microbits. You'll see it's enabled over here, and when we click on here, it's just got 2 set up. It just makes it a whole lot easier to get your motors up and running rather than having to code a whole lot more. It's effectively just a function that is built in over here. So we can drag this in and say that if motor direction is 0 or has the value of 0, then motor 1, which is the one that we're going to connect up, you'll see in our next step, that's what we do. Then it should go forward at the speed of speed. So we want to call this variable over here. And so whenever this happens, whenever it receives that, it's going to constantly check for that if motor direction is 0, and then it'll go forward at that speed. We also want to run a check for, whoops, wrong place. If motor direction is 1, then the motor 1 should not be moving forward, but should be reversing. So this is a nice, easy, and quick way of getting our motor to either run forward or reverse at the same speed. Now, of course, you could change this. You could set up a new variable. You could set up some math in here that says that when it goes forward, then it's speed plus whatever, or speed divided by something if we wanted it to go slower. I'm not going to do that, but you can certainly play with that. Now, what could happen, or what you could set it up with, are different events, like when on button A pressed, or when I receive this, or something like that. I found that your forever loop updates a lot more frequently so that it responds quite quickly, rather than on button presses, which will cause the motor to go just a little bit jerky. Okay, our last thing that we want to set up is a while loop. So a while loop keeps running while a condition is true, and as soon as that condition is not true, whatever's in this block is false, then it'll stop running the code inside here. So we want to check while speed is, we'll just drag this one in over here, while speed is greater than, I'm going to choose greater than or equal to 0. So whenever speed is more than 0, this code should run. And that code is going to be us changing, see I went to variables there, changing speed by -1. Now that might seem strange at first, but what that is going to do is make sure that when we are not pushing a button on our other microbit, that our motors stop, and stop relatively quickly. You can cause your motor, you'll see by changing this value to something much lower, 0.2 for example, that'll cause your motor to slow down a lot slower. I found -1 works quite nicely. If you wanted to stop pretty much immediately, you could make that a much bigger value, a much larger value like that. I'm going to stick with -1 for the moment. And so in here is all the code that we are going to need for our 1 microbit. You can go ahead and click download and put this code onto your microbit now if you'd like. It's always a good idea to name your file. I'm going to call it motor driver, and what do we call it? Rover. Motor driver rover. You can click save for later. I will be uploading this file just by the video so that you can download it and compare. Please make sure that you're just comparing rather than using my code. If you do this, you will understand it a lot better. And as you change things and move things, you might see a lot more clearly what changes what and what influences different aspects of this build. But we've got one more little bit of code to set up for our other microbit. So this one should already be on our 1 microbit. Now let's set up the radio microbit, the one that we're going to be using effectively as a remote control to tell our rover whether or not it should be going forward or reversing. So let's go over to our radio functions over here. Make sure that we set our radio group to 1. Remember, this needs to be the same as your driver microbit. And then I also like to just put this in so that I know when this microbit is ready and that the batteries are all working and everything like that. Then this is where we could say on button A pressed, then send a radio signal or a radio number. But I found that this is what makes your motor very jerky. So in fact, we're not going to use that. Instead, we're going to use our forever loop and some conditions. So we'll look under logic and use another if statement. So we're going to check if the A button is being pressed, then our microbit should send the number 0, telling our microbit to go forward. So let's do that by going over to input, looking for this kind of triangular, or whatever you want to call it, one diamond shape, elongated diamond shape one. If button A is pressed, then this microbit should send the number 0. So that'll tell our other driver microbit to go forward. Button A then is for moving forward. Obviously, if you want to change that around, then you could change this value. I'm going to once again duplicate this so that if we press button B. Then it should send the radio number 1. Remember, radio are other microbit. If it receives number 1, it's setting the variable, assigning the value of 1 to the variable motor direction, which in our other, this sounds complicated, which in our other code then tells our other microbit driver to reverse. I'm just going to call this one radio controller. Radio controller Rover. And then I would download this to the other microbit. Okay, so if you have put that all together nicely, then it should, if we get all of our wiring correct, work quite nicely. If you've got any questions, if you've got a much better idea about how to do this, or you know a way to make this just way more efficient, then please do let me know. Thank you very much and enjoy. All right, now that it comes to the wiring and the actual build, because I assume you have done the coding, I remember that you might not get that coding right first time. You might need to go back in, try out a few different things. I actually encourage that. Try out different different values for the variables, different timings, different ways of doing it. Remember, if you find a better way of doing this or just a different way, then just let me know. That'll be really, really cool to see what you come up with. Okay, let's have a look at the few things that we have over here. We've got our 9-volt battery as well as the holder, which we are going to be able to attach. You can see my one's looking a little bit beat up because I broke it, but I managed to fix it. Luckily, insulation tape solves a whole lot of problems. We've got our motor driver board, which I spoke about. In order to get the wires in there nicely, we'll need our screwdriver. We've got a USB cable to connect our microbits to our laptop. I haven't put it in here, but I assume you know you need a laptop or a mobile device with the Makecode app on it. We've got a battery pack which has 2 AAA batteries inside. That'll be to power the extra microbit that we'll use as a remote controller. You are welcome to, of course, just use your USB cable attached to your laptop, but obviously that reduces mobility, so I just don't think it's ideal. In this build, you'll see that I've cannibalized slightly a Lego block, one that's used to power a Lego motor over here, which I've already attached to a few blocks. This is really helpful if you are using Lego to do your build. Otherwise, you're very welcome to use any other motor, like this one, different size ones. As long as it can be powered by a 9-volt battery, then you are good to go. You'll see in this build, if you are quite attuned to it, that I haven't used any other kind of electronics or things like that, because I just want to keep it nice and simple, and the motor should be fine, should have enough resistors and things in there and over here that regulates the flow. You shouldn't need to worry about blowing any motors or anything like that. Okay, let's get on to how we'll put it all together. Firstly, we'll start off by attaching our battery. Now, very nicely, our motor driver board has actually labeled for us red and ground, which you can sort of see there, red and black. Black is generally the color that is used for ground. So for these, what you'll do is carefully insert it there, use your screwdriver to clamp down. My wiring isn't great over here just because I've done this many, many times with this wire. I really should just strip it and get a bit more, but this will just be for illustrative purposes. The black one, the ground, goes in here as well. And what's really nice about this is that you don't need an extra battery pack for your microbit. This 9-volt battery will power the whole thing. Next up, what you can do, let's attach the motor. So I've attached these over here. I haven't used specific colors or anything like that, but I am making sure that it goes into motor 1. You can also see what's really cool is that if you wanted to use these for other things, you've got this accesses pin 12 on your microbit, and that one accesses pin 8. You've got for motor 2, other inputs. We can even connect 4 buttons over here. And yeah, we haven't used any of that for this one, but it is just nice that it is there. So let me get that nicely in there and screw it on down, as well as this one. Now you might not know which way it goes around at first. That's all right, you're welcome to change it to make sure that your forward is actually forward and your reverse is actually reverse. Now again, what's cool about this is that I can just attach this directly onto the motor over here, just making sure that it's making a nice connection with that. That gets it done. Otherwise, what you would do if you're using a normal motor is just put these two in there, or use some extra wiring if you wanted a little bit more space. Okay, great. And now this is the microbit that I put the longer code on, the one that's actually going to be driving, the one where we set up all those variables and things like that. Very importantly, make sure that the LEDs and the front of the microbit is facing this way. If you put it this way, it's another cool function, but we're not going to use it for this build, that it opens up all of these pins so that you can access them, effectively an edge connector. So I will just slot this in, and there you see it has already come on. Now, I might not be able to demonstrate this because this battery is dead. All the ones that I've used are dead. The other ones are in the mail, on the way. So this will most likely not power it, but you can see that tick that shows us that it is ready. Then we will use, on our other microbit over here, our battery holder. You can just slot that in nicely. That should also show our tick if it's ready. And like I say, this probably won't turn the motor now. When I push, yeah, you can see our microbit died over there because it just doesn't have enough power. That's actually pretty amusing to watch as well. So what should happen when I push A is our motor should run forward, and when I push B, it should run backwards. I'm all right with that because you're going to be able to go on see that in the build. Then, what I've done over here, which you would have seen in the first build, is I have set this up so that I can connect this, okay, the wiring's all over the place now because I haven't done it properly, is you connect this over here, and you've got, pretty difficult to show you on this, you've got these two gears that connect. Let me take this piece off. You've got these two gears over here which are going to connect and run that, so as the motor comes on, then that'll drive it forward and back, and then I've just connected to other whatever kind of wheels over there for stability. That's the part where you've really got to use your green thinking hat. You've got to be creative in how you do that. So that's how you connect the wiring, and enjoy.